Hello everyone, welcome to session 2 of chapter 1 Alkenes. In the previous session we have seen nomenclature and synthesis of alkenes. In this session we shall discuss addition of hydrogen bromide to propene. During this addition we are also going to discuss Markovnikov's rule. Propene, when we write propene, look here. Propane, it is a derivative of propane. Propane means 3 carbon containing hydrocarbon. So we have 1, 2, 3 carbon containing hydrocarbon. It is propene, so it has a double bond. It is immaterial, you can put double bond here or you can put the double bond here. Okay. So now we are going to discuss addition of HBr to propene with mechanism. This is propene. We are going to add HBr. We are going to discuss the mechanism. So this is an addition reaction. Okay, it's an addition reaction. So all addition reactions take place in 2 steps. The first step is addition of the electrophile and the second step will be addition of the nucleophile. So when an addition of electrophile occurs first, such reactions are called as electrophilic addition reactions. If at all you have nucleophiles adding first, then they are called as nucleophilic addition reactions. And if you have free radicals adding first, they are called as free radical addition reactions. So there are 3 types of addition reactions: electrophilic addition reactions, nucleophilic addition reactions, and free radical addition reactions. Okay. So here, while we discuss HBr getting added to propene, it is an electrophilic addition reaction. Here, see, addition of HBr to propene is an example of electrophilic. Sorry, this is not substitution, it is addition reaction. Hydrogen bromide provides the electrophile, which is H+. This electrophile attacks the double bond to form a primary and a secondary carbocation as shown. So we have a double bond here. So when H+ acts, see, this is pi bond. Pi bond itself acts as nucleophile. So it is electron rich. H+ is electron deficient. Therefore, here you have to show an arrow mark from double bond to H+. You should show an arrow mark here. When this happens, so either carbon number 1 will become positively charged or carbon number 2 will become positively charged. See here, in this case you have carbon number 1 becoming positively charged if hydrogen goes to carbon number 2. If hydrogen goes to carbon number 1, then carbon number 2 becomes positively charged. So you have 2 types of carbocations. Okay, whenever you're going to write the mechanism, you have to show arrow marks. Kindly add an arrow mark here. So it shows an attack. We have to observe here, these are 2 types of carbocations. So this is a primary carbocation and this is a secondary carbocation. I have told you in the previous classes, primary carbocation means a carbocation which has 1 alkyl substituents or no alkyl substituents. So here it has 1 alkyl substituent. This is ethyl, which is substituted with 1 carbon atom with positive charge. So it becomes primary carbocation. In this case, you have 2 alkyl substituents. So it is a secondary carbocation. We know while we have discussed stability of carbocations, tertiary carbocations are more stable than secondary and secondary are more stable than primary. Here we have secondary and primary carbocations. Here secondary carbocation is more stable than primary. Hence this will be formed in major quantity. Okay. Next what happens is attack of nucleophile. Look here, the arrow mark is from Br minus to this carbocation. This is electron rich to deficient center. So the secondary carbocations are more stable than primary carbocations. Hence the former predominates since it will form at a faster rate. Thus in the next step, Br minus attacks the carbocation to form 2-bromopropane. So this is going to happen. This will be the major product. If Br minus attacks this, you are going to get 1-bromopropane, which will be a minor product. So 2-bromopropane is the major product. This reaction follows Markovnikov's rule. What is Markovnikov's rule? The negative part of the addendum is attached to carbon atom having less number of hydrogen atoms. So what is an addendum? Addendum means any molecule that gets added to the unsaturated molecule. Here what is getting added? Here HBr is getting added. So HBr becomes the addendum. When you dissolve HBr in water, you are going to get two ions, H plus and Br minus. Okay. So the rule says negative part of the addendum. So we get H plus and Br minus, which means the negative part of the addendum here is Br minus. It attaches to the carbon having less number of hydrogen atoms. So let us look at this molecule once again. This is propene. We have two hydrogen atoms on carbon number 1. We have one hydrogen on carbon number 2. So addition is going to occur across these two carbon atoms. One will get H plus, other one will get Br minus. So Markovnikov's rule says negative part, which means Br minus, goes to that carbon atom with least number of hydrogen atoms. When you compare carbon 1 and carbon 2, carbon 1 has 2 hydrogen atoms, carbon 2 has only 1 hydrogen atom. So the negative part should go to carbon number 2, which means Br is going to attack carbon number 2 and H is going to attack carbon number 1. So we can see here, that is what has happened here. We have got H here and we have got Br here. So the major product will be 2-bromopropane. Okay, that is Markovnikov's rule. Once again, let us look at Markovnikov's rule. Markovnikov's rule says that in addition of an unsymmetrical alkyl halide, unsymmetrical alkyl unsymmetrical reagent. Make this as in addition of an unsymmetrical reagent to an unsymmetrical alkene. Check here, this is an unsymmetrical alkene. Symmetrical means if you cut it into two halves, it has to be two equal halves. Okay, that's not happening. So this is unsymmetrical alkene and this is an addition reagent. Okay, so which is unsymmetrical reagent. Kindly do not consider this alkyl halide. It is addition of an unsymmetrical reagent. Okay, strike this alkyl halide. It is unsymmetrical reagent to unsymmetrical alkene. The negative part of the addendum is attached to carbon atom having less number of hydrogen atoms. So this can be even stated in terms of hydrogen. That is, in addition of unsymmetrical reagent to unsymmetrical alkene, the positive part of the addendum is attached to carbon atom with more number of hydrogen atoms. Excuse me. So we have seen in this particular session addition of HBr to propene, and we have even discussed Markovnikov's rule with mechanism of this particular addition reaction. Okay, thank you.